Hello everyone, this is Mrs. Rabab speaking, the science teacher. I hope all of you are in good health and all of you are ready, inshallah, to start studying using this method. We will start, inshallah, again with Unit 1, Investigate Matter, Model 1, Matter, Lesson 4, it will be Solid, Liquids and Gases. In your textbooks, you will follow the pages from 49 to 51, again, Unit 1 book. Objective of this lesson will be to be able to know the scale and organization of particles in matter and to be able to describe solid, liquids, and before I start with the lesson, I would like to do a quick revision for matter from term 1. I'm sure most of you might probably forget what is matter or the definition of matter or how to describe matter. I would like to start with the revision before I proceed to the lesson. Matter. Matter, anything that has mass and takes up space. Remember when I told you mass, what does mass mean? Mass means how heavy an object is, or the weight of an object, any object. And the meaning takes up space, meaning how this object occupies itself in space, or how much this object takes volume, for example. Everything around you is matter. You are matter, the air is matter, water is matter, everything around us is considered to be matter. Like us and, for example, the ball. Mass. The amount of matter or stuff in an object. What does mean the amount of matter inside an object? Meaning, how heavy is the object? Can I weigh it? Can I know how much the weight of the ball, for example? Yes or no? Of course I can. That means it has matter in it. We measure mass in grams and kilograms. Paper example. Paper clip has a mass of about 1 gram. A liter of milk has a mass of 1 kilogram. So each example has different weight or different mass. You can measure mass with a balance. If you remember balance from our activities, balance or a pan balance or even electronic balance, all of it can measure mass or how heavy an object is. I would like you all to open the textbook on page 49 when it says lesson 4 launch particles in matter. So, 4 friends were talking about the particles that make up matter and give matter its properties. They each had different ideas. Let's see. Just let it load for a minute. This is what they said. Who do you agree with most? Joyce said, I think you cannot see the particles that make up solid, liquids, and gases. They are too small to see. Harold said, I think you can see the particles that make up solids, liquids, and gases. Royce said, I think you can see the particles that make up solid and liquids, but you can't see the particles that make up gases. Benito said, I think you can see the particles that make up solid, but you cannot see the particles that make up liquids and gases. I want you all to take a minute and think about which one of these friends is correct. The correct answer will be Joyce. It's because particles in matter are too small to see with ordinary magnification tools. The arrangement and movement of particles determine the state of matter. So you cannot actually see the particles that make up matter that easy with magnifying glass or with your naked eye. So you only know what type of matter is how to see the arrangement of the particles inside the matter. This is the way that you can figure out, is it a solid, is it a liquid, is it a gas, depends on the arrangement of the matter itself. Is it tightly packed? Is it not packed at all? Is it looks random to you? Whatever the arrangement is, you can figure out the state of matter. This is the model answer in page 49 for the explanation part. Please take the time to copy the model answer in your textbook. It is important to have written notes in your books. Please copy the answer. Now we'll move to the main objective of the lesson, which is the state of matter. I think everybody knows that matter comes in three states. State of matter is one of the forms that matter takes, such as solid, liquid, and gas. Very simple example for solid, which is the ice cube. Ice cube can melt and become liquid again. When it's become liquid and you want to boil water, it will transform itself to gas and become water vapor. For every state of matter, there is a definition, of course. Let's start with the solid. What do you think the definition of solid will be? Take a couple of seconds and think about, if I want to describe solid, how can I describe a solid to someone? Solid should look like what? It's like what? The texture will be like what exactly? So the definition of solid has a fixed volume and a fixed shape. What does it mean it has a fixed volume? Meaning if you want to break it down, it will not break down easily. For example, take a pencil. You can break your pencil, of course, but if the pencil drop on the floor, it will not get broken easily. So the volume that the pencil take in the space did not change, so it's fixed. Also, the shape of the pencil. If I drop the pencil on the floor, does the shape change? Think about it. Does it become something else? No. So the pencil definitely is solid matter. It's not liquid. It's not gas. Another example, think about a chair. What happened to the chair if I throw the chair in a swimming pool? I pick up the chair and I throw it in the swimming pool. Does the chair disappear? No. Does the chair change shape? Does it look like a table now, for example? No. Does the chair reduce in size? No. Increase in size? No. If I weigh the chair before I throw it in the swimming pool, and let's say the chair is 1 kilogram, for example, let's say a small chair, or 2 kilogram, and I throw it in the swimming pool and I pick it up again, I weight it again. Well, the mass will be different. No, it will stay the same, 1 kilogram or 2 kilogram. So any example that can describe solid, that it has a fixed volume and fixed shape, will be solid. State of matter will be for it is solid. Wooden block moved, or the example I told you earlier, which is the chair, the amount of space it takes up also stay the same. The mass doesn't change and the volume does not change. Now liquid. Liquid has a fixed volume but not a fixed shape. A fixed volume meaning the amount of liquid that takes up space or occupies space is the same. Very simple example, always memorize it. I have water inside a glass. Let's say 100 ml of water inside the glass. If I transfer the same water from a glass to a bottle, for example, does the amount of water got less? No. Got more? No. What happened to the water? Only it changed shape. That looks like a glass from the beginning, then it changed to a bottle later on. But the amount of water inside both, it's the same. Unless if you don't spill it, of course, but it's the same. Transfer it from the bottle to a bowl, for example. Also stay the same. It only took the shape of the bowl. It did not change volume. It only changed shape. Vinegar is an example of a liquid. Water is example for a liquid. Milk example for a liquid. Any liquid is good example for state of matter, which is liquid. So let's say if you pour a liquid from one container to another, its shape changes. Yes, but the volume stay the same, meaning the amount of water inside the container will not change. Lastly, the definition of gas. Gas has no fixed volume or fixed shape, meaning gas is not stable. Gas is all around us. Right now, you're sitting at home or in your room and you're listening to me, and there's gas around you. You don't actually see it, but it's there because you're breathing in and breathing out. All right? But in order to see the volume or the shape of a gas, you have to put it on some kind of container. For example, very simple example comes to mind is the balloon. When you blow the balloon, the air inside the balloon take the shape of the balloon. That means it has no fixed shape. And I don't guarantee that all the entire air will be inside the balloon. Of course not. The volume will change. The volume will change. It will not be 100% the same. Helium in a balloon, air, normal air that we breathe, and steam are example of gases. This is the end of this video. Thank you so much for listening and watching. Have a nice day all.